Right, should we have a quick talk about this? Well, I'll tell you what I'll do. Okay, think about it a slightly different way. So I would like an algebraic solution, so not drawing a snowman on my board, Miran. Okay. So let's just think of the situation. So we've got Sean and Jada collect seashells. Sean began with 400. So that's an important piece of information. Sean began with 400. All right. And then we've got that Jada began with 20. All right. Now, the other thing we know is that each day, Sean found 20 shells every day. Okay. But then what we've got is Jada found 40 shells every day. So if we were just to write that out, so Sean started with 400 shells. So day one, how many shells does he end up with? 420. Day two, he ends up with
440.
Day three, he ends up with
460.
day four,
480.
day five. Okay, well let's talk about Jada then. She starts off with 20. So day one, she's got 20. Day two?
40.
No, because she finds 40, so 60. Then 100, then 140, then
180.
then
220.
then
260.
so she's still not got as much as him. What I could keep doing, do you remember doing common multiples? It's kind of doing the lowest common multiple thing, but it's slightly different because it's not just multiples. Now, what I would rather do though is come up with an algebraic approach. So what I'm looking for is, what's the unknown again? How many days? So I've got 5, 6, 7 days. Now after 7 days, Sean's got 540. Jada's only got 260. So I'm looking for the day. Which day, should I call it D? Which day is this number equal to that number? That's what I'm looking for, yeah? So, how do we figure out how many shells each one will have? So day one, Sean has 400 plus 20. Day two, Sean has 400 plus
40.
I'm going to write 2 lots of 20. Day three, that's 400 plus 3 lots of 20. What about Jada? Jada has
220 plus 40.
Actually, this should have been 60 from the start, shouldn't it? Because she started with, I did that wrong. So actually, Jada started with 20, and then on day one, at the end of day one, she had 60. Okay? Or instead of saying 60, I'm going to have 20 plus 40. The next one, she had 20 plus 2 lots of 40. The next day she has 20 plus 3 lots of 40. Okay. So that's how we build it up. Now over to you to figure out what the D is and how you can relate it to these things and then solve for the D. For how many days. So there's my help. You ought to be able to apply something at that point if you think it through. Alright? Right, I'm going to go through it because I know Tiasia's got it. Cameron listened. She's got it now. Right, this is how we do this kind of thing. So I know what I have to be able to do is analyse the situation and figure out what's going on. So for instance, we started here and we said, well, the next day would be 400 plus 4 lots of 20, 400 plus 5 lots of 20, 400 plus 6 lots of 20, and so on. Alright? Now, what I was saying before is, what we don't know is how many days we keep going on. So what I'm looking for is, can we write an expression that uses whatever number of days I have and works out the number of shells? So hopefully you've noticed that 4 lots of 20 on day 4. Day 5, 5 lots of 20. Day 2, 2 lots of 20. Yeah? So what about day D, Cameron, instead of scribbling on your board? How many shells does Sean have on day D? Or day X, or whatever you want to call it?
400 plus D.
It's 400 plus
20D.
20D. D times 20, or 20D. Because that means he starts with 400, and every day he gets another 20. So it's 400 plus 20 for every day.
Can we just do that? It's easier.
It's not easier, it's different. D for days. X for... You've got to get used to it. I understand you might be used to seeing X, but we're not always going to see X's. So I don't want to make it easy so that when you get a test and it now says D for days or M for meters or whatever, you don't know what to do because it's not an X. Yeah? So that's what Sean has after D days. Now what we want is Jada to have the same amount after those D days. So what will she have after the same D days?
20 plus 40D.
20 plus 40D. So 20 plus 40 every day. Alright? Can you see my algebraic equation now? And what do we do? I can see you starting there. Taylor?
Take 20 away.
So take 20 away. So basically what that's doing is saying, right, let's take away the amount that Jada started with. So take the 20 off, and we've got to do the same for Sean. So take 20 away. So that gives me 380 plus. So basically I'm saying I'm taking away those 20 from both people to get it out of. So I'm trying to get down to how many days. Now what can I do?
Divided by 40.
I could,
Or minus.
but I can do something else first.
30, 380.
I could, but again I've got no 380 or anything on that side. What am I going to do? No.
Take away 20.
Take away 20 D. So this is 20 days worth. This is for. So let's take away 20 days from both sides, and I'm left with, well, Sean has 380 shells, and Jada takes 20 days to get to 380 shells. No, it's 20 lots of the number of days,
So
not 20
now
days.
you can divide by
Now we can divide by
120.
20. Okay. And I get with D equals, well, divide by 10 first. So 38 divided by 2 is
19.
19. So D is 19. So what does that mean? How long was the holiday?
19 days.
19 days.
19.
Can you see how much easier that is?
Yeah. I missed it.
You
I
missed
had
it, see?
Ha ha ha.
How many shells did they have after 19 days?
780.
And how would I find that out if I've got my algebra?
Wait, I missed that.
So after 19 days, how many shells did they have? How would I find out?
19 times 3.
For who?
For G. I mean,
For Jada?
yeah.
So Jada has 20 plus 40 times 19. Sean has 400 plus 20 times 19. So how much is that? So that's 400 plus, I'm going to do, it's 2 times 10 times 19. So that's 2 times 19, we've already got is 380. So that's 380. Okay. So he has 780. What does Jada have? Well, it ought to be
780.
780. Should we check? So it's 20 plus 4 times 10 times 19. Okay. So that's actually double 380. So that's 760,
So can you give us
which is 780. Okay?
So can we have another question?
One like that. I haven't got another one like that, quite like that. But what I'm going to get you to do now is I'm going to get you to solve more equations like that. So, do you agree? Really, the hardest bit is forming the equation in the first place.
Yeah.
But that's the bit we have to be able to do. So quite often we just learn how to do it, but we don't really know where it comes from. So doing a question like this shows you that you have to be able to build up that equation as well. Right? So in your textbook, could you please turn to page 88? Page 88. Right, on page 88 you have exercise 3E.2. Alright,
Do we do all the questions?
so you're going to have a go at all of them. So do you want me to do one with you first? Or are you alright? You're all good?
Okay, actually, yes. Actually, no.
Well, I tell you what, I'll do the first, the easy one with you. Okay? So the first question is, we've got to solve 5x plus 2 equals 3x plus 14. Now can I ask, actually, if you had to turn this question into a Sean
A what?
and Jada shells question, alright? How would you say what they've been doing? Before we solve it, how could we write a Sean and Jada shell question using this information? So we might actually, I'm going to rewrite it another way for you and say it's 2 plus 5x equals 14 plus 3x. So what could I say? Sean starts with how many shells? 2 shells. Jada starts with 14 shells. Sean collects
5
5
X
shells a day.
Jada collects three
shells
shells a day.
a day.
And they and at
So,
the end
We have the same type of thing here, don't we? At the end, after how many days are they equal? So that's why I've got the equals. So if we were going to then solve that for x,
how would
we go solve for x. What do we do? Cameron, what would you do first?
I would do take away 5.
Take away
2.
Take away 2, okay. Take away 2 because of that one, yeah?
Yeah.
So I have to take away the 2. Now, I take away 2, that's a 2 and not a 2x or anything. So it's taking away 2. So what does that leave me on this side? Just 5x. And on this side,
12
12
plus 3.
plus 3. Now what do I do? Taylor, concentrate. No, you're drawing a line in your book and then you won't know what to do. You don't yet. Just concentrate and then you can write it up.
So then you would divide by 3.
No, you would take away the 3x.
Right, let me just ask you this, right? If I were to divide by 3, so if I divide by 3, what would I get? Now, you guys have quite rightly said I wouldn't do that, which is good. But if I did divide by 3, what would it look like?
X equals whatever.
So this side I would divide by 3. That would be messy.
Yeah.
But I have to divide the whole side by 3.
Yeah.
Yeah? Everything by 3. I think what Maron was saying was, let's divide only this bit by 3. But do you remember when we talked about the order, when we talked about it as a language, it's x times 3, then add 12. Yeah? So I can't divide by the 3 without getting rid of the 12 bit first. Or if I do, I have to divide the 12 by 3 also, yeah? Now what would that give me on this side? 12 plus 3x split into 3 groups.
4 plus x.
4 plus x, great. This one would be
Not even.
5 over 3x. That's not very nice, is it? Right? So that divide by 3 thing, it didn't prove to be very nice at all. Alright? So, we could do that. However, that would lead us to a problem, wouldn't it? So that's the bit there. The 5 over 3x would be the problem. So what do I do actually?
You take away 3x.
So we take away the 3x, and I get
12.
2x's is 12,
Then you divide by 2.
then divide by 2, and we get
X equals 6.
x equals 6. So in this case, if it was a Sean and Jada on holiday collecting shells, how many days?
6.
6. And how many shells would they both have?
12.
It's the thing, you get the solution, and what do I do with it? So x equals 6, so you got
Sean get 32?
32, yeah?
Oh.
So Sean,
Jada would get 32.
exactly, 5 times 6 plus 2 should equal, this is how you can check if you're right, 3 times 6 plus 14, it should equal. If it doesn't equal, you've done something wrong. So this is 32, and this is 18 plus 14 is
32.
32. So we know we're right. That's the great thing about maths. Check your answer, know you're right. Okay? Because we are saying that one side has to equal the other, so we ought to just check that it is. Yeah? So this is the check. So I might choose to do that in my head, but you would not believe the number of people that, let's say they've done this, they make a slight mistake and they come up with x's something, And all they needed to do was put it back in to check that both sides are equal, to know that they were wrong and made a little mistake, and they don't bother. Lose all their marks.
No. So that question could be worth 6 marks and they get 0.
Yeah, exactly.
Well, when's you gonna mark for your working out though?
Depends
Well,
where
they
your
would
mistake
get
is.
1.
If your mistake comes straight at the beginning and it's a basic mistake that you shouldn't have made, no, they
Then
wouldn't.
no.
Exactly, yeah.
Whatever.
Right, go on.
Okay.
You're going to
What's
ask
like
me?
a common mistake?
A common, it doesn't matter. If it's a common mistake, that just means that lots of people have the same problem in their knowledge, so they're not going to give a mark just because you make the same mistake as everyone
Or what
else.
if it was a silly
If they're, well again,
Then you wouldn't get a mark either.
I would say also, we've got to be very careful with this word silly mistake. Because silly mistake suggests that you wouldn't do it next time. But a silly mistake,
You would do it again.
Like, what if they got the concept right, but they like.
so
they
for
said
instance,
2
what would be a
minus
silly
6
mistake?
was
Lots of
silly
people say,
mistake.
oh, have I dealt with negative numbers? Oh, that's a silly mistake. When actually they do the same thing wrong every time. That's no longer a silly mistake. That is a what we call a misconception. They don't know what to do. If they do 2 times 1 is 3, and of course they know that 2 times 1 is actually 2, they just add it by mistake. That might be a silly mistake,
Yeah.
but it's
but
only a silly mistake
if they know,
if it happens once.
and if they know that the other answer is like no.
Yeah.
Or like if you ask them,
If it's-
or like what if they do a silly mistake on the test, but then you want to make sure that we actually know the answer, so then you ask us and we get it right the second time. Then
Yeah, then I would know, that would be my assessment, that it was a careless mistake on your part and I don't need to worry about it too much. But that's what I tend to do, is it not? When you've done a test, I will ask you certain questions and see whether you do know or don't.
Cool.
But you should do the same thing. Don't just put everything down to silly mistakes. Anyway, do you want to carry on with some of those questions? Have a bit of practice. It's been a good chance to practice.